Hi, welcome to section 2.4, compound inequalities and interval notation. So we're actually going to flip that around. We're going to do the interval notation first, and then we'll finish up with some compound inequalities here in a little bit. But let's get started. So what we're looking at here is we're going to be doing some inequalities. So just as a basic review, I have the inequality x is greater than 3. Now hopefully we all remember this means x can be any number that's bigger than 3, but it can't actually be 3. Remember, it only includes this number if we put a little line underneath that inequality sign. So in this case, x has to be strictly greater than 3. Now, as you can see, I made a graph, and hopefully you remember making graphs of these. I used an open circle because we're not including the 3. My arrow is going out to the right because x is all the numbers that are bigger than 3. And if you need to, pick a number that you know works and point the arrow that direction. So in this case, I have x is bigger than 3, so I go, hey, 4 is a number that's bigger than 3. 4 is over this way. That's where my arrow is going to have to go. Now, we want to transition into something called interval notation. And you'll see it here behind me in just a second as soon as I move out of the way. But basically, we're going to make a switch. And when we look at our graphs, instead of using an open circle to represent a number that's not included, we're going to use a parenthesis. And we'll see what we use for the equivalent of a closed circle here in just a minute. So you'll notice that I switched my graph, and I have a parenthesis here at the 3. That shows that it's not included, and the arrow is still going out to the right. Now, let's look at the interval notation. So for interval notation, here's what we're looking at. For this one, it would be 3 comma infinity. And what this is it's a piece of my number line that starts at 3 and goes out to the right forever, and so that's why we put infinity there on the right-hand side. What you want to do, and I wrote it down here, is that it should match the graph. So since when I look at the graph of x is greater than 3, I have the parenthesis on the left-hand side, and that's where 3 is. You'll notice that 3 is on the left-hand side of my interval. It goes out forever to the right, so that's where I get a positive infinity. You would never write this as infinity to positive 3. That wouldn't make any sense. If the arrow is going to the left, and we'll see an example of this here in a minute, we'll use a negative infinity on the left-hand side. And we'll, like I said, we'll see that here in just a minute. So a couple of other points here. We use parentheses as the equivalent of an open circle. The number is not included. That was this example. And we use brackets if the number is included. So the brackets are the equivalent of a closed circle. And for those, the number will be included. And again, it should match your graph. So let's take a look at some more examples. All right, so I've got 2 more examples on the board, and then we're going to move on to some other fun stuff. All right, so first, -2 is greater than or equal to x. All right, so for this one, you can see I drew my graph first. That's what I did. I drew my graph first. Because I have the line underneath, I know that the -2 is included, so I'm going to be using a bracket. Remember, no closed circles and open circles anymore. We're going to be using parentheses and brackets. So I put a bracket there, but I have to again decide which way is the arrow going to go. In this case, it's going to the left because x is the smaller thing. So again, pick some numbers that work. Or you could pick something that you know doesn't work. Like for instance, if you picked 5. 5 is, -2 is not greater than or equal to 5, so 5 doesn't work. It's got to go the other direction. So I made it going this way. So when it came time to make the interval notation, this time, since we're going forever out to the left, I put a negative infinity on the left-hand side of my interval. For the right-hand side, there's my -2, and I use a bracket because the -2 is included. We never put a bracket on infinity or negative infinity. That doesn't work because infinity is a concept. You can't actually get there, so we don't put a bracket there. We always use a parenthesis for infinity. Second one I have is x is less than 5. Again, this is an arrow going out to the left because x is all the numbers smaller than 5. This time I have a parenthesis because the 5 is not included, and you'll see my interval again. Again, it's going forever to the left, so I have my negative infinity on the left-hand side. 5 is on the right-hand side, and it gets the parenthesis. All right, so now we're going to look at solving we're going to solve some inequalities with these, and then we'll get to the compound inequalities. All right, so now we're going to look at solving inequalities. The good news is I have the steps here. They're pretty straightforward. It's just like solving equations, okay? Just like solving linear equations, at least at this point. Step 2 then is this. This is the only difference we have. Flip the sign if you multiply or divide by a negative number. Okay, so anytime you multiply or divide by a negative number, you're going to turn that sign in the middle around. Now, one thing to watch out for, here I had to subtract 5. I have negative 2x plus 5 less than or equal to 7. So I need to subtract 5. That doesn't flip the sign. That's subtraction. It's not multiplication or division. So even though it's a minus 5, I don't need to turn it around. So I subtract the 5. I get negative 2x is less than or equal to 2. But now I am dividing by negative 2 on both sides, which means 2 divided by negative 2 gives me negative 1, but I had to flip that sign around. Okay, please be careful. Don't change these to equal signs. Some people do that. Just learn to work with the inequality sign in the middle. You're probably better off that way. All right, so then the answer I want is this interval notation down here from negative 1 to infinity with a bracket on the left. But if it helps you to get that, feel free to make that graph first. Okay, it only takes a second to make that graph. I have great confidence that you guys can do that. And it will really help to make the interval then. Because again, the interval should match the graph. So since my bracket was on the left-hand side of the part that worked here, my bracket is on the left-hand side of the part that works. So anyway, that's just something to keep in mind. Let's do like 2 more examples of that, and then we'll get to the compound inequalities, and those are fun. All right, a couple more examples, and then we'll move on to the compound notation, which is really pretty fun. All right, so negative 2/3 x plus 7 less than or equal to 5/3 x plus 6 is our first. So I started by subtracting the 6. There are lots of places you could have started on this one, but that's where I chose to start. That gave me a 1. So then I had to add the 2/3 x to get rid of the x on the left-hand side. So I did that, which left me with 1 is less than or equal to 7/3 x. Okay, so I multiplied both sides by 3/7. Remember, if you have a fraction on the x, you can always multiply by its reciprocal to get rid of it, right? Because the 3's would cancel, the 7's would cancel, and so they'd be gone. You'd just be left with x. So I get 3/7 is less or equal to x. Notice this time I did not flip the sign in the middle because 3/7 was a positive number. Okay, so since I was multiplying both sides by a positive, I didn't need to switch it. So then I made the graph because, again, it's useful to make graphs because then we can see exactly what our interval looks like. So I know it starts at 3/7. I know it's got a bracket because the line is underneath, so we're including that. And this time x is bigger than 3/7, so I put the arrow going out to the right. And so my interval starts at 3/7 with a bracket and goes out forever to infinity. For my second example, here we have some parentheses we have to deal with. So we have 5 times x minus 2 is less than negative 3x plus 5. So I got rid of the parentheses, gives us 5x minus 10. I chose this time to add the 3x to both sides. I like positive x's, so makes things easier. So I add 3, 5 and 3 is 8. This time I forgot to write it down, but I added 10 to both sides. That's where I got 15. And I divide by 8. So I get x is less than 15/8. Again, I didn't switch the sign because I divided by a positive number. One other thing I'm going to point out here just real quickly, I like the fraction. The fraction is beautiful. This one comes out pretty nice as a decimal. If your decimal comes to an end, you can write it as a decimal if you would like. But the other thing is here, I don't need this written as a mixed number. You could write it as 1 7/8, but I don't need you to. So feel free to leave it as 15/8. So again, I made my graph. There's 15/8. This time I used a parenthesis because the number was not included. And since x is smaller than 15/8, my arrow came out to the left. And my interval, this time the 15/8 is on the right-hand side, right? It's the right end of that interval. And it goes forever out to negative infinity. All right, now we're ready for some compound inequalities. All right, so we're ready to start looking at compound inequalities. Compound inequalities have multiple pieces. So they come in 2 different forms, or and. And we're going to look at both of them. Feel free to watch this video a few times, at least this part of it, to kind of get the hang of this, because sometimes people get a little wonky here. All right, so here's the first one, or. I have x is less than 3, or x is greater than 6. Or means if one of those 2 criteria is met, that's a good value for x that works. So when I make the graph, ors are going to generally, almost always, end up with two distinct parts of the graph. Okay, notice I have x is less than 3. Here's that part of the graph. I used a parenthesis. My arrow goes out to the left. I have x is greater than 6. I start at 6. There's a parenthesis. My arrow goes out to the right. For or, any number that's either out here or out here will work. Okay, it can be in either place and be just fine. We write that using interval notation basically like it looks on the graph. It's still two separate parts. Here's that first part. The 3 is on the right-hand side of that interval, so with a parenthesis, and goes out forever to the left to negative infinity. Or we start at 6, again with a parenthesis, and we go forever out to the right to positive infinity. Now, one bit of notation that you might see here is a U in between. So you might have the two sets of parentheses with that U instead of the word or. That is what's called a union symbol, and it basically means the exact same thing. So if you see that U, that's all that means. And I'll take either one. So that's or. And is different. And is more exclusive. For and, both parts have to be true for it to be a good value of x. So for instance, here I have x is greater than or equal to 2 and x is less than or equal to 6. Both of those things have to be true. Now, for x is greater than or equal to 2, that would start at 2 and go forever out to the right. For x is less than or equal to 6, that would start at 6 and go forever out to the left. But we want them both to be true at the same time, and that only happens in between 2 and 6. So you can see I put two brackets there, and in between, that's the only part that works. So what does the interval look like? Well, there are no infinities this time. It starts at 2, it goes to 6, and that's it. I have brackets on both ends because they were both had the equal to bit, but it could be parentheses. And so it's also important to note that this inequality, x greater than with two separate parts and an and, could also be written like this. Because what an and really is it's x is sandwiched in between those two numbers. Now, one thing to really be careful of when you do this, and this will happen a lot more when we get into the solving this kind of stuff, make sure that the order works. 2 is smaller than x is smaller than 6. That makes sense. If for some reason you had that turned around, you would have 2 is bigger than x is bigger than 6. And that doesn't work all the way from left to right, right? 2 wouldn't be bigger than 6. So just be careful with that. All right, let's solve some of these. All right, let's go ahead and solve. So I have two examples again, an or and an and. The and is kind of hiding behind me right now. You'll get to see it in a minute. So here's my or. Notice it just looks like I'm solving two things. That's really all I'm actually doing. So I have 3x minus 4 is less than 8. I have negative 2x plus 6 is less than or equal to negative 10. I'll let you work through them. I have all the work here on the board, but we end up with x is less than 4, or, keep the or, x is greater than or equal to 8. So there's my two parts of the solution. You can see I made a graph. So I started at 4, went all the way out to the left because x is smaller than 4. That gave me this interval from negative infinity to 4 with a parenthesis on the right. And then I made a mistake. Look at that. Then I had x is greater than or equal to 8. So I used a bracket on the graph, and then I made a mistake there. There we go. Now we have a bracket on the interval 2. Starts at 8, goes forever out to positive infinity. For the other one, all right, this is the different one. This is our and. This sometimes messes people up. So the first question, just kind of a rhetorical question real quick. How many pieces are there? 1, 2, 3. This is going to work the same way as anything else you've ever solved, but you have to do everything in 3 places instead of 2. So I need that x by itself, so I'm going to add 1 to get rid of the 1, but I have to also do it on the left and the right. Then I have to divide by 3. But I also have to do it on the left and the right. So I'm left with 2 is less than or equal to x is less than 5. Again, this is where you want to be careful. Make sure that those numbers make sense in the order that you have it written. If they don't, something went wrong. In this case, again, you could draw the graph, but the interval is just from 2 to 5 with a bracket on the left and a parenthesis on the right. So good luck. Thanks.